Okay, so before we start our today, I just want to go over some of the exponential equations that we see most often, because we do usually cover that in grade 11. So the four exponential equations that we see most often is the one used is the one where you have a 1 minus I to the power of n and y equals 1 plus I to the power of n. Now, you might see them written differently with different letters, but they all mean the same thing, right? It's the same form. We use these two equations whenever we have a rate, okay? So that percentage. So an example would be if you put a certain amount of money in an account, right? So that's your principal amount, that's your initial amount. You put that initial amount into the bank, and then you're gonna get 5% per year on that, right? So that 5% represents your I, and then n represents the number of years, okay? So we use this whenever we are given rate, which means percentage, okay? And what the letters represent, we have two different formulas for a reason. This represents decay, so a decrease. And this represents growth, which means an increase. Okay, so the 1 minus the I, that represents your decay. The 1 plus the I, that represents your growth. Now, letter A, let's start with letter Y first. Y represents your final amount. A represents your initial amount, so what you're starting with. I represents your rate in decimal, so not in percentage. So for example, if you have 5%, we write that as 0.05, okay? So we don't write it as 5%, we write it as 0.05. So we divide the 5 by the 100, and we write that as an I. And then n is the number of years. Okay? So these letters mean exactly the same thing for the growth formula. Okay? As I said, the only difference is that it's 1 plus I or 1 minus I. And the difference becomes the following. If I have growth, right, if the question is saying that you put an amount in the bank and then you're getting 5% interest every year, right, you're going to get more money on top of your initial amount. Does that make sense? Right? So let's say this is your initial amount. Then you do 1 plus 0.05, right, to the power of n, and whatever your initial amount is. Let's say your initial amount is $2,000. Right? So what you see here is I have 2,000, 1.05 to the power of n. I apologize for the color. Can you guys see it? Now, if I have a decay, so let's say if I have an amount of bacteria, and then I gave them some antibiotics or whatever, medication, and then what's going to happen is that the bacteria is going to decrease by, let's say, 5%. But in this time, I use the word decrease, right? It's going to decrease by 5% every whatever. So in this case, it will be y equal to, again, I'm starting with 2,000 bacteria, and then it's going to decrease, so it's going to be 1 minus 0.05 to the power of n. So that gives me 2,000, and that's going to be 0.95 to the power of n. So you see here, the difference is going to be for anything that's a growth, your base is going to be greater than 1 because you're going to add to the 1. So it's going to be 1 plus a number, right? Because it's 1 plus a number, right? It's going to be always greater than 1. Does that make sense to you? For growth. For decay, on the other hand, it is going to be always between 0 and 1. So it's going to be less than 1. Okay? So it's always going to be 0 point something. 0.95, 0.5, 0.8, 0.6. Okay? This represents a decay. This right here, the 1.05, represents a growth. So whenever you look at your base, the base is the one that has the exponent on top of it, right? So this is your base right here because it has the exponent on top of it. Whenever your base is greater than 1, then it's growth. If your base is between 0 and 1, then it's a decay. Does that make sense? Okay? And then again, if I have a rate question, I'm going to start with either one of these formulas, either y equals a1 minus I to the power of n if I have a decay, or a1 plus I to the power of n if I have a growth. Okay? And then you know it's a growth or a decay by looking at the words. It's either a decrease, an increase, right? Usually these are the words that they use. Okay? Or growth or decay. They use these words as well. Are you guys okay with this type? So this is what we cover in grade 11. Okay? Then the other two type of equation that we use, they're the special case ones. And they're the ones that deal with half-life and doubling. Okay? If you took chem or bio, you probably have seen some of these equations. So the two other equations are the half-life one. So again, it's y equal a half because it's half-life to the power of n over h. That's the letter n. That's the number of years. And then for the doubling, it will be y equal a 2 to the power of n over d. These equations, yes, n over h. So again, y is going to be your final answer or your final amount. A is your initial amount. The reason why it's a half, because it's half-life, right? So half-life, that means my base is half. That means I am decreasing by half of the amount every time. So if I start with 1,000, then I'm going to have 500. Then I'm going to have 250. Then I'm going to have 125. So I am decreasing by half of the amount every single time. And that's why my base here is half. So that's a base, right? It's 0.5, which means it's half-life. That won't change for half-life. For the half-life, the base is going to be 0.5. N is the number of years, but the important part here is, so this is the number of years or number of periods, let's say. H is your half-life time. Usually that is given to you. Okay? So that's your half-life time. So let's say if you have a radioactive isotope of carbon-14, let's say, and then we know that the half-life of carbon-14 is some kind of 1,000-year, okay? When I say the half-life of a carbon-14 is 1,000, that represents the letter H, okay? Because I'm giving you a half-life time, okay? So every 1,000 years, you're going to decrease by a half. That's what it means. Okay? Usually that H is given to you. Similar to that, I have the double life, right? Double formula. So this is your final amount. This is your initial amount. That word initial was not working well with me. This is 2 because we're doubling, right? Doubling means 2. So your base is 2. That's an increase. N is the number of periods, either in years or in days, whatever. And this is your doubling time. Again, usually that's given to you. Okay? So let's say you have a bacteria count, and the bacteria count is doubling every 10 hours. Right? So that 10 hours is the D, because it's doubling every 10 hours. So after 10 hours, you're going to have, let's say the first amount you have 1,000. After 10 hours, you'll have 2,000. After 20 hours, you're going to have 4,000, right? After 30 hours, you're going to have 80,000, right? Because 1,000, 2,000, 4,000, 8,000. Are you guys okay with these formulas? Okay. So we have exponential relations are modeled by an exponential equation. So y equals a, and I have a base. The base can either be found by 1 plus I, 1 minus I, or it's the half, or it's the double. Okay, so that's why we say it's a base. And then to the power of x. What does A represent? Initial amount. Or value, right? What does B represent? We call B your either growth or decay factor. It depends if it's greater than 1 or if it's between 0 and 1. So we call that the growth or decay factor. If B is greater than 1, is it growth or decay? If the base is greater than 1? Growth. And if the base, I'm going to fix to between 0 and 1 instead of less than 1. It's not usually negative. If the base is between 0 and 1, then we call this growth or decay? Decay. And remember that B could be any of the following. 1 plus I. If b is greater than 1, then it will be 1 plus I. It could be 1 minus I. It could be the half. It could be the double. And then some case we have the triple as well, right? Where if it's triple, then it will be 3, right? It depends what the question is asking exactly, right? But then at the end, if I have a rate, when I add the 1 plus the rate, it's going to give me a number, and that's my b, right? Here's a question. A city's population can be modeled by the equation P equals 1.4 bracket 1.0415 to the power of t, where P represents the population in millions and after t years after 1985. Okay? So what will be your first year? What will be your year 0? 1985. All right? Year 1 is going to be 1986. Right? Year 2 is 1987. So this is why this is important to state. It's because I need to know what year is this scenario applicable to. In which year did the population first exceed 3 millions? Okay? Let's first look at our equation. P is replacing what letter? Huh? Yes, but in my original equation, what letter is it replacing? Y. 1.4 is replacing what letter? A, which means that's my initial population, right? Now 1.0415 is representing what letter? It's B, it's your growth factor. And why did you say growth? It's because it's greater than 1. You see that base is greater than 1. That means it's representing the growth, which means in turn it's representing the 1 plus the I. Right? So that 1.0415 is actually 1 plus I, and this is how they got this. Right? So it's 1 plus the rate. We'll talk about that in a second. And that letter t, which is the exponent t, is representing the exponent x. Right? So, what's my beginning population? 1.4 million. Now the question is asking you in which year. So I'm looking for what? What letter am I solving for? T. In which year did the population first exceed 3 million? So what is my ending population? 3 million, because that's what the question is asking me for. Now, if I'm asking you, what is the rate that is the population is growing at? So what letter am I looking for? What is the rate? I am solving for t, because that's what the question is asking for. But for this specific question, population is growing at a rate of what? 4.1? 5? Yes. But how did you get that? 1 plus I. Yeah, which is the rate. So, guys, remember that the rate means the letter I. Yes? That's what the rate represents in that equation. Now, I know that my final answer is 1.0415. And I know that I got this by doing 1 plus I. If I want to solve for I, what do? bring the 1 over and becomes minus 1, yes? So that becomes 1.0415 minus 1, and that gives me the I. 1.0415 minus I, so that's equal to 0.0415, which is in percent. Which is in percentage. If I multiply this by 100, it's going to be 4.15%. So to solve this specific question, so the population is growing at what rate, then this is what I do. I take the 1 plus I because I know it's a growth, and I subtract the growth factor. I subtract 1 from it. Now, yes, I multiplied this by 100. To get the percentage. When I do 1 minus 1.0415 minus 1, I'm going to end up with 0.0415, yeah? So the question is asking me to solve for t. If I take the equation, it's p equals 1.4 times 1.0415 to the power of t. I know what my final population is going to be, right? Which is 3. And I'm looking for t. What do I do to solve for t? What? Solve for t. How do you solve for t? Isolate. How do you do that? What's the first thing you want to get rid of? The 1.4, right? So you want to bring the 1.4 over. It's a multiplication here, so that becomes 3 divided by 1.4, and that's equal to 1.0415 to the power of t, yeah? So that gives you 2.1426. I wrote it as many decimal place. Now, how do you solve for t? But can you? That t is in the exponent, right? Do I know what it is, though? I don't. Right? So I don't know if it's 2, if it's 3, if it's 4, if it's 10, right? So I can't take the root because I don't know what root to take. Right? So we learned yesterday that if I have good numbers, whole numbers, we learned that we put them to the same base, right? We have the same base, and then that would give me my exponents to be the same, equal. But that's kind of impossible here, okay? The only way I can do this type of questions right now is by doing trial and error. So just do plug in values for t. So do 1.0415 to the power of something, 1.0415 to the power of something, until you get as close as possible to the left side. Okay? So give me some trial and error. What are you going to try for? Give me a number for t. 2. What do you get when you do to the power of 2? 1.08. I can't hear you. 47. Is that any close to my answer that I'm looking for? Is it close? No. Right? Yes. To the power of 18? Okay, so let's write 1.18. So what did you get for 1.18? Sorry, for 18? 2 point. Yeah. And then if you do 19, okay, so you're going to have to plug in some numbers until you get to a number that's close to it. Now, if I look at both of these numbers, 18 or 19. Oh, I forgot to write the 19. 5, 3. So I look at this. 19 is my most suitable answer. Technically, it's between the year 18 and 19 is when I'm going to reach the 3 million. But because I'm looking at over 3 million or exceed 3 million, then I will use the year 19. Okay? I'm going to say, therefore, year 19, which was 19 years after 1980 something, I will reach a population of 3 million. Okay? Now, in this case, we've had few people trying different answers, right? But technically, you should be doing trial and error for all the numbers that you can think of until you get to the nearest answer. Okay? So your answer is going to be for this one. Therefore, the population reaches 3 million. Between the years 18 and 19, or so if I do 1985 plus 18, that's going to give me 2003. So in year 2003 is when the 3 million will be reached. Okay, so basically this is doing the trial and error. I'm going to teach you a formula that you can use so you don't have to spend too much time doing trial and error. This formula is not in the curriculum, so if you want to do trial and error, feel free to do so. It's not in the grade 12C curriculum, but I mean, I'm going to show you a shortcut. You don't want to use it, that would be great. You don't want to use it also, it's not mandatory. We talked about these two formulas prior to the lesson, at the beginning of the lesson, where we have the doubling and the half-life. Yes, you see them a little bit differently. I used y equals a to n over d, which is exactly the same thing. It depends on what letter you use. So in this case, instead of using a0 or a0, which is for initial value, we use A. Instead of using big A for the final amount, we use Y. So it's exactly the same thing. It's just different letter. Okay? Doesn't matter which way you see it. It's the same thing. It means exactly the same thing. and D represents the half life. D represents the doubling, yeah, thank you. So time it takes for population to double. And then for H, it's the time it take for the initial value to be reduced in half. All right. So as I said earlier, we usually, if we're solving for the exponent, right? So whenever you're solving for the exponent, you can use what we call the logarithm formula to solve for your exponent. If you look on your calculator, there is a button that says on it LOG, which is log. Okay? So basically, the formula says that to find the exponent x, you do the log of the answer and you divide by the log of the base. Okay? So to find the exponent, it's equal to the log of the answer over log of the base. So if I want to solve something that looks like this, 5 equals 1.06 to the power of x. I can sit down for 5 minutes and try values for x, and then hopefully get to something that's very close to it, okay, by doing trial and error, because I need to get it equal to 5. So I can sit down and say 1.06 to the power of 3, 1.06 to the power of 10, 1.06 to the power of 15, 1.06 to the power of 20, right, until I get an answer that is equal to 5 or as close to 5 as possible. But I can also use that formula that I just showed you to solve for x right away. So to solve for x, it says it's equal to log of the answer over log of 1.06. Okay? So on your calculator, you're going to do log of 5. And then you're going to divide it by log of 1.06. And what did you get as an answer? 27.6. So x equals 27.6. Are you going to be able to find that answer exactly if you do trial and error? No. Right? But when I do this formula, right, I'm getting an exact answer. Now let's try. If I do 1.06 to the power of 27.6, so 1.06 to the power of 27.6, I got an answer of 4.993. Is that close enough to 5? It is. Yes? So all what I had to do is I had to write the formula punch it into the calculator, find the answer. Right? So I don't have to actually sit down and do same base, right? And then solve for the exponent and whatever. Now, how about this? I'm looking for the exponent again. What do? What is my exponent? What is it? So 2x is equal to, yes? Because that's my exponent. Log of 25 over, exactly. Now, if I do log of 25 and divide it by log of 0.97, I'm going to get a negative answer, should be. I'm going to get negative 105.7. Okay? Now, is that my final answer? What else do I have to do? Divide by 2, because I want to solve for x, not for 2x, right? So in this case, there's one extra step. You want to get rid of that 2, so you have to divide both sides by 2, right? So you can get rid of that 2, and that gives you 52.8. Is that right? Negative 52.8. Are you guys okay with this? Okay, can you try the next one, please?